सो हे गाइस एंड वेलकम बैक टू माय चैनल। सो फाइनली हमारी पूरी टीम ने डिसाइड कर लिया है कि हम एक यूट्यूब चैनल खोलेंगे और रोज एक या दो या तीन जितने भी हो पाएंगे हम वीडियोस जरूर अपलोड करेंगे एंड वी विल कीप यू अप टू डेट। और जितनी जल्दी हो सके हम आपका सिलेबस भी खत्म कर देंगे। सो या फाइनली अभी हम स्टार्ट करने वाले हैं और मैं आपको एक और बहुत इंपॉर्टेंट बात बताने वाली हूँ कि हम जो सब्जेक्ट्स पढ़ने वाले हैं इस चैनल पे वो है इंग्लिश, साइंस और मैथ्स और कंप्यूटर की भी बात चल रही है। सो जो भी चेंजेस होंगे मैं आपको बता दूंगी, ठीक है। एट द एंड ऑफ द वीडियो आई विल लेट यू नो। सो या लेट्स गेट स्टार्टेड। तो आज हम स्टार्ट करने वाले हैं चैप्टर 4 से, जो कि आपके आईसीएससी 10th का बहुत ही ज़्यादा इंपॉर्टेंट चैप्टर है और लगभग लगभग 12 नंबर के क्वेश्चन इसमें से हर साल आते हैं। सो पर्सनली मेरे को आईसीएससी का बहुत ज़्यादा वर्किंग एक्सपीरियंस है, ये मैं आपको बताना चाहूँगी। सो या लेट्स गेट स्टार्टेड। अब हम कोर्स को चालू करते हैं। तो गाइस अभी हम जब फिजिक्स चालू कर ही रहे हैं तो मैं आपको ये भी बताना चाहती हूँ कि हम कौन सी बुक फॉलो कर रहे हैं। सो वी आर फॉलोइंग कॉन्साइज फिजिक्स बाय सेलिना पब्लिशर। और बहुत सारे आईसीएससी स्कूल्स में यही फॉलो हो रही है, नहीं तो आप ये भी फॉलो कर सकते हो कैंडिडेट आईसीएससी फिजिक्स, ये भी बहुत अच्छी बुक है, बट आई विल प्रेफर कॉन्साइज फिजिक्स मोर। ओके सो या यस लेट्स गेट स्टार्टेड। तो अभी हम चालू करने वाले हैं फोर्थ से। So today we are starting the topic टॉर्क एंड कपल। ओके तो आज का हमारा जो भी क्लास होगा हम उसमें टॉर्क एंड कपल की थ्योरी डिस्कस करेंगे। फॉर न्यूमेरिकल्स वी विल हैव अ सेपरेट वीडियो इन विच वी विल डिस्कस ऑल द न्यूमेरिकल्स। ओके सो या लेट्स गेट स्टार्टेड। सो ये तो आप सबको जरूर ही पता होना चाहिए व्हाट इज फोर्स। अगर आपने अपनी आईसीएसई 9 अच्छे से पढ़ी है तो आपको ये जरूर ही पता होगा, और नहीं भी पता होगा, अगर आपने नहीं भी इतना अच्छे से करी तब भी आपको आई थिंक 70% को तो पता होगा ही। सो व्हाट इज फोर्स? इज इट अ पुश, अ पुल और अ पुश, अ पुल, बोथ? सो you have 5 seconds. Think. Okay, so a force is a push or pull, okay, which can produce the change in its shape or in its size. ये आपको अब तक तो पता होना ही चाहिए। लाइक आईसीएससी में 6th में स्टार्ट हो जाता है फोर्स का कॉन्सेप्ट एंड नाउ यू आर इन 9th। अब तक तो आपके बेसिक्स बहुत अच्छे से हो गए हैं। सो या now we are familiar with force, like there are many types of force: normal reaction force, force of friction, tension force, and a lot of them. Okay, so yeah. So what do you think that a force can produce? A linear motion, a rotational motion, or both linear and rotational motion? तो आप में से बहुत लोगों को नहीं पता होगा व्हाट इज लीनियर और रोटेशनल मोशन। तो लीनियर मोशन में आपको एक और बात बताना चाहती हूँ कि लीनियर मोशन को हम ट्रांसलेशनल मोशन भी बोलते हैं, ठीक है। तो इट इज अ मोशन which takes place along a straight line. Okay, it will always move along the straight line, like a body which is free to move and moves in a direction where the force is applied. And when we come to rotational motion, a rotational motion is the one which takes place about an axis of rotation. ओके तो मैं आपको एक और बहुत इंपॉर्टेंट कॉन्सेप्ट बताना चाहती हूँ कि हिंज, पाइवेट, ये सब सेम वर्ड है। एक्सिस मतलब ये जो मिड पॉइंट होता है ना उसको ही रेफर करते हैं, जो कि मैं भी आपको आगे भी बताऊंगी कि एक्सिस ऑफ रोटेशन, हिंज पॉइंट और पाइवट पॉइंट ये तीनों सेम है। ओके तो आई थिंक आपने अब तक तो थोड़ा सोच ही लिया होगा माइंड में कि व्हाट अ फोर्स कैन प्रोड्यूस। सो या अ फोर्स कैन प्रोड्यूस बोथ लीनियर एंड रोटेशनल मोशन। So let us think that how can a force produce both linear and rotational motion? You need to think about it. Okay, first give your mind some time so that it thinks something. Okay, yes. Okay. So now you need to consider two metal rods. Okay. In the first case, it is completely free to move, while in the second case, it is fixed at one end. It can't move completely. So now we will apply force on both the cases. In the first case where it is not fixed, and in the second case where it is fixed at one end, pivoted and hinged, both, all three are same. Okay, just don't get confused. ये आपको एग्जाम में ट्रिक कर सकते हैं. ओके, तो कंफ्यूज मत होना. And about the notes also, I will let you know in the last part of this video. Okay. Yes. So what do you think that in which cases the rod will rotate? It will not move, it will rotate. Okay. So yeah, it will move in case 2, not in case 1. In case 1, it is not fixed, so it will move in a straight line. While in case 2, it is fixed. So it will move about the axis of rotation, about this pivoted end, where you can see the arrow. In translation motion, the rod moves in a straight path in the direction of force. Okay? Yes. So we are done with the translation motion now. Okay? Yes. Now we will move forward. Now we will come to rotational motion. So a point at which the object is fixed is called pivot, and the object is known as pivoted. Okay, this is the fixed end. This is known as hinge. This is known as pivot. This is the axis of rotation. All three are same. Just don't get confused, okay? That's the key point that I want to tell you right now. Okay, in rotational motion, the rod moves about the fixed point or the pivot. I've already told you about that. Okay, yes. Now we will consider two more examples. In these cases, the rod won't move. Why? First, we need to study the diagram. Okay, so in the case 1, it is applying the force on the pivoted point, while in the second case, the body is also pivoted. Okay, so we can come to a conclusion that in both the cases, the body is pivoted. While in the second case, the force is applied on its free end, where it is free to move. So, why do you think that the rod will move or won't move? And if not, why will it not move? So, okay, so let's figure it out. So, to find, let's draw a line along the force. So, you need to draw a line along the force, and this extent of line is known as line of force. Remember this key term, line of force. It is very important. Reasoning questions can come in your exam like this. The line of force is passing through the pivot, so the rod will not move, so the rod will not rotate. Move or rotate are the same thing. Okay, so there's a condition like if the force, the line of force is passing through the pivoted point, the rod will not move or the object won't move. Okay, so now we will do some numericals and some reasoning based questions. In which of the cases the body will turn? All are pivoted at the center. See, okay, now I think you all can do this. This is very easy. You just need 2 seconds for this. Think. Okay, so the answer will be B. Okay, because in all the forces, the force is passing through the line of action of force. The force is passing through the pivoted point. Okay, remember these key terms. These are the 2 key terms. Can any force cause rotational motion? Yes or no? No, not all force can cause rotational motion. Okay, only the tangential force. Okay, now this is a new term for you. Maybe tangential force means that a force which is applied tangentially. You must be knowing what is a tangent. Okay, yeah. Like see this point, the force is applied tangentially. Does rotational motion depends on the magnitude of force only? So like if I am applying the force over here, it only depends that how much amount of force that I am applying, or there is some other factor also. No, the rotational motion doesn't depend on the magnitude of force only. So now I think you need a more detail of this. So let us understand this by taking a real life example. You must have seen how door rotates around one end. It is pivoted or hinged around one end. And here we apply a force. Okay? Yes. Now we will take three cases, like if I'll apply in the first case we are applying on the handle. In the second case we are applying in the middle of the door. And in the third case we are straightly applying it on the pivoted point. Okay? So think like, what do you think that in which of these cases it will be easier to move the door or open the door? Okay? Yes. So what do you think? Absolutely, case 1 will be the right answer. So see, could this be the reason why the door handles are placed at the other end? Because there is the maximum distance from the pivoted point. If I will apply the force on the handle, I will get the maximum distance from the pivoted point. See, the distance D is maximum over here. So the rotation depends on two factors. First is the magnitude of force applied, and second is the perpendicular distance between the pivoted end and the line of action of force. So to study rotation, we need to combine force and distance. This combination is known as torque. Okay, torque or moment of force, they both are same thing. So mathematically, torque is equal to force into the perpendicular distance. So yeah, I want to tell you that we while we will do numericals, we will not straight away write torque. We will represent it by a symbol which is known as tau. Okay, like in Hindi we call it tau na. Yeah, the same thing is here, but the accent is like different. So it will be tau, not tau. Okay, so torque is defined as the product of force and the perpendicular distance between the line of action of force and the pivoted. What is the SI unit of torque? I think you guys can configure it out. Take the SI unit of force and the SI unit of distance. You will get the SI unit of torque. That's the best thing that you can do. Okay? तब तो निकाल लिया होगा. So the right answer will be Newton meter. Because the SI unit of force is Newton and the SI unit of distance is meter. If we will combine both of them, what we will get? It will be Newton meter. Yes. So the CGS unit of torque is 9 centimeter. Okay, yeah. And the KGS unit is not included in our syllabus, like the syllabus is reduced. So we will not do that. Okay. Yes. Now let's move to next topic. So we will do like only one or two numericals in this class, but I will keep a separate class for the numericals. Okay, so don't worry about them. If you are not able to do them, just don't worry. I will also be uploading my notes in the description box. Okay, you can just go and check it out. I'll be letting you know that how you can take it out. So, oh, sorry. So consider a door having a width of 2 meter is being applied by a force of 20 Newton. Consider a door having a width of 2 meter is being applied by a force of 20 Newton at the door handle. What is the torque obtained? Okay, so torque is equal to force and the distance. The force we have over here is 20 and the distance is 2. If you will multiply 20 into 2, you will get 40 Newton meter. And I think that's a right answer. Okay, so you got it right. And yeah, let's check for other numericals as well. So a body is pivoted at a point. A force of 10 Newton is applied at a distance of 30 centimeter from the pivot. Calculate the moment of force about the pivot. Okay, so The trick in this question is that they haven't given you the distance in meter. They have given it to you in centimeter. So now you need to convert centimeter into meter. So 1 meter is equal to 100 centimeter, and 1 centimeter will equal to 1 by 100 meter. I think now everyone can do this. Okay, use your own brain. Then only you will be able to do that. Okay, so the right answer will be 3 Newton meter. And the rest of them we will be doing in our next class. Okay, so don't get worried about it. We will be having a separate video in that we'll be doing it. So yeah.
So now the question arises that can a single force cause rotation if not hinged at one end? So yeah, the answer will be no. A single force cannot produce rotation motion. So now we will study it with the help of a real life example. Consider a tab. See, there are two forces which are equal and opposite, okay, and they are of the same magnitude. These forces are equal and opposite, I've told you. Two equal and opposite force not acting along a same line forms a couple. You can see the examples while opening the cap of the ink pot, while driving, okay, the motion that we produced in the steering wheel, and there are some other examples also. The turning effect produced by the couple is called moment of couple. Okay, yes. Can a couple provide rotation in both direction? Like it can move anti-clockwise also or anti-clockwise also? Yes, it can move. So the type of moment of couple first is clockwise and another is anti-clockwise. So while we consider clockwise, we will take the value negative, and when we will consider anti-clockwise, we will take the value positive. Okay, yeah. Next. So the moment of force, okay, so this is a description of this diagram. You can just go through it. I don't think that this is that much important. So mathematically, the moment of couple is equal to either of the forces into the perpendicular distance between them. The SI unit is Newton meter. We will be also doing one numerical regarding couple, and then it will be done. Two forces, each of magnitude 2 Newton, act vertically upward and vertically downward, respectively, at the two ends of a uniform rod of length 1 meter, which is pivoted at its center. Determine the resultant moment of force about the midpoint of the rod. So, what you need to do is 2 multiplied by 1, and you will get the answer, because we have to take either of the two forces, both will be equal. Okay, so 2 into, and the distance here is 1 meter as it is specified over here. So the answer is 2 Newton meter. I think ये बहुत आसान था. Like you can easily do 2 into 1. It will hardly take you any time, and we will do rest of them, okay, in class. Okay, like the separate video, as I have already told you. We will do one more over here. A steering wheel of diameter 0.5 meter is rotated anti-clockwise by applying two forces of 5 Newton. Calculate the moment of force applied. Okay, so now I think you can do this. Okay, no conversion is required in this one. You only need to do 0.5 into 2. 0.5 into 5. Okay, yes. The answer is 2.5 Newton meter. Okay, yeah. So yeah guys, then that's it for this video, and by the end of this video now you will be knowing everything about torque and couple. In the next video we will be also going through equilibrium and numericals on torque and principle of moment, center of gravity, uniform circular motion, centripetal force and centrifugal force. Okay, yes. So about notes, I want to tell you that I will provide it by the end of the chapter. Okay, however I'll do it, I'll just let you know in my next video, but for this video I will not provide it to you. But the last video that we will have, like for uniform centripetal and centrifugal force. And yeah, guys, I'll post all the important concepts from this chapter that you need to know. Okay, you can go through them. And yeah, that's it for today's video. सो या गाइस, और मैं आपको एक बहुत इंपॉर्टेंट टिप देना चाहती हूँ कि जो भी आप बुक फॉलो कर रहे हो, कॉन्सेप्ट सारे सेम होंगे, बताने का तरीका अलग हो सकता है थोड़ा बहुत, बट एवरीथिंग रिमेन्स द सेम. तो आप अपने चैप्टर के थ्रू जाना, और जहाँ भी आपको डाउट आए आप कमेंट कर देना मेरे को. ओके या, सो थैंक यू फॉर दिस वीडियो, और अब हम अगली वीडियो में मिलते हैं. थैंक यू.